GAC Precal12. This is part 2 of our podcast in Chapter 7. Hope you're having a great day today. We're going to go into some of the specific problems that, well, you need to kind of make sure you're familiar with, that you can go through, and we'll go through those together. If you do have any other questions, individual questions, please make sure you come tomorrow morning. We'll look at that together, and yeah, we'll navigate through that together. So let's get right straight to it. Go to some of these problems. Some of these are on the review, while some of these are, well, they're not. And so you may want to just make sure that you use some of those similar problems to be able to dissect the ones that are on the review. Make sure that you understand every one of these problems. One of the ones that I would just be leery of is ones with systems of 3 equations where you can't use a matrix capability. Make sure you know how to use that matrix capability, but there is one where you will not have that ability. So just be sure you know how to use your calculator and also know how not to, okay? All right, so with that being said, we're going to get right straight to some of these problems that are here, specifically one like the one on top here. Solving the system without using a matrix capability. Again, when I have an x squared here, the one thing to remember or to look at is that there's a possibility that there could be 2 solutions. Now, that may not always be the case, but there is a possibility that is there. The easiest way to do this is to be able to solve this by maybe doing some sort of elimination. Could use substitution. But I see that this negative 2y is here, and so I want to make that y on the bottom 2y. So I'm going to multiply all of these values by 2, which produces a new equation of 6x squared plus 2y plus 2 equals 2. Now, this is equation number 2. I'll circle it there. We're going to bring down equation number 1, which would produce x squared minus 2y minus 5 equals 0. Now, when I set these equal to each other and I solve this, we can simplify or solve this by canceling these out and getting 7x squared minus 3 equals 2. Okay, equals 2 there. Now, in solving this, I'm trying to see if this is me or not. We'll keep going. We're going to add 3 to both sides. Add 3 to both sides, so we get 7x squared equals 5. Now, when I divide by 7, these will cancel, giving me x squared is equal to 5 over 7. So once I square root both sides, I get x is equal to plus or minus the square root of 5 over 7. Now, in order to simplify this, and I want to make sure real quick, oh man, that is a problem. Actually, let me backtrack, because as I looked at this, I messed up on a sign, which threw off the answer that was here. All right, let me backtrack. Did I throw that off? I don't think I did. Multiplied by 2. I think I actually got that one correct, I think. Just want to make sure I'm dissecting that. 2 and 0. Actually, no, I didn't. My fault, because I had dropped it down. So actually, once I get to the end, this answer right here, which would be the square root plus or minus the square root of 5 over 7. This right here would be, we could leave it like this to be really mathematically correct. That'd be the square root of 5 over the square root of 7. So we could multiply top and bottom by square root of 7 here to give me square root of 35 over 7 with a plus or minus there. Because again, we don't like square roots in the bottom. Now, this one is a tougher one, probably one of the tougher ones we'll look at, and one that we'll look at, maybe another one here in just a second. Let's say that I got to this plus or minus the square root of 35 over 7. But this time, let's say that I get rid of the x squared. So let's say that I multiply this by, let's say negative 3, okay? So on the top, we would get negative 3x squared plus 6y plus 15 equals 0. Let's bring this is equation 1. Equation 2, we drop down 3x squared plus y plus 1 equals 1, my fault. So when I combine this, the x squareds cancel, giving me 7y plus 16 equals 1. Subtract 16 on both sides, subtract 16, to where we get 7y equals negative 15. I divide by 7, divide by 7. Y is then equal to negative 15 over 7. So the x was plus or minus the square root of 35 over 7, and then y would be negative 15 over 7. Now, coming to another one, and I'm going to actually go to the one on the review because that was just a good practice for us. I think I had one on the review. Very similar. I don't think it's the exact same. Let's do number 8 on the review, maybe more like the test. If I multiply the top by negative 3, produces negative 3x squared minus 6y plus 15 equals 0, right? On the bottom side, I keep it the same because I'm trying to cancel out those x squareds that are there. Cancels out here. So I get negative 7y plus 14 equals 0. Now this works out a little bit nicer because once I subtract 14, I get 7y equals negative 14 divided by 7. Y is equal to negative 2. So we can hold on to that. Now, in a different color, we'll go yellow. We plug negative 2 back in for a y. Let's do the bottom equation. And I'll put it over here. Over yonder, 3x squared minus negative 2 minus 1 equals 0. So then we add this. So we got 2 minus 1, which would be 1. So we got 3x squared plus 1 equals 0. Subtract 1, subtract 1. 3x squared equals negative 1. Okay, so once we kind of solve this here, we subtract 1. We can divide by 3 on this. Divide by 3 to where x squared is equal to negative 1 over 3. Now, when I square root both sides, I get x is equal to plus or minus the square root of the top, which is 1, over the bottom square root, which is the square root of 3. Now, with this negative inside, but if I have a negative inside, it actually comes out as an I, and I multiply top and bottom by the square root, which would in this case be square root of 3. So this would be plus or minus I square root of 3 all over 3. Okay? Now, since this I is in play, what that means is that this specific example actually doesn't have a place where it crosses at x, because then I is an imaginary number, not a real number. Okay? And so even though I had a y, which was in this case negative 2, if I plugged it in, whether I plugged it in for the top or whether I plugged it in for the bottom, the answer for this would still produce the same thing. It would still be the same thing there. And so it's just something kind of important to note when solving for any one of these, that that within this case we have an imaginary number I that allows us to say that actually we solved it, but there is no place where this system would intersect. It would be as if two let's say parabolas, one went up and one went down, let's say, there would be no places where they would intersect. And so that's why in this example, there is no x value that's there, right? All right.